Hi, how are you guys doing? It has been a long time since I posted my last video. I have been very busy, but now I got some time. So I thought to myself I should start posting videos again. At the same time, when I went to the supply chain conference last month, I saw people were very much interested in knowing how we can apply predictive and prescriptive analytics techniques with respect to supply chain. And this is all about data, right? Companies have lots of data, but very few companies know how to apply those data in right areas to improve their performance. If you Google predictive and prescriptive analytics with respect to supply chain, you won't find very good example and applications. You can find how Google is applying those data, Amazon is applying, Airbnb is applying, or Walmart and Target is applying big data in their operations. But you will not find specific examples with respect to supply chain. So I think it's a right area. If I post some video, that would help you guys very much if you're working in the supply chain area. So I would start posting more than one videos on this topic. In each video, I would present one example and I would relate that example with predictive and prescriptive analytics with respect to operational supply chain. So in my first video, I'm going to talk about dynamic ABC inventory classification, and I would relate this topic to predictive and prescriptive analytics. Many of you, if you guys are already working in supply chain and inventory management, you will be very much aware of what is ABC inventory classification. And most of you guys would be working in ABC classification when you classify inventory, and you would be using just one criteria. And most of the time that is annual dollar usage or the forecast. And that classification we call classical inventory ABC classification or single criteria ABC classification. So before I explain dynamic ABC inventory classification to you guys, it would be very good for you to understand what are the different types of ABC inventory classification is available. So one is single criteria that you guys already know. Second is multi-criteria inventory classification. So in the multi-criteria, you guys use more than one criteria that is more relevant to your supply chain. In my world, I use annual dollar usage, cost, and inventory obsolescence, and in some cases I use customer lead time or supplier lead time, sorry. How multi-criteria is more beneficial than single criteria. So let me explain it to you. In the multi-criteria, when you use more than one criteria and then you apply the total score on each inventory item, that total score would help classify each inventory item. Okay. In your supply chain, in my opinion, more than one variable would be involved in increasing or decreasing the inventory level, right? For example, if lead time, take an example, lead time, okay? If lead time is very short enough that you can replenish those items in a very quick fashion, then in my case, you won't need to have very high inventory level on those items. But in some cases, when your supplier lead time is less than your lead time to your customer, in that case, you won't need to have any inventory on those items because you can get those inventory items within your lead time. For example, if your supplier lead time is 2 weeks for any specific item, but your lead time to your customer is 4 weeks, then you guys don't need to carry any inventory, right? So similarly, when you have so much when your lead time from your supplier is very high and your customer lead time when you are quoting to your customer is very small, then you will not be willing to face any stock out on those inventory. So we need to carry high inventory on those items. So and this was one criteria, okay, lead time. And second, the cost. If the inventory cost is very small, then you can carry more inventory because it won't hurt you too much. But if inventory cost is too high, then you should be very cautious when you stock some inventory. So that could be another good criteria. And third criteria, since I am in the IT industry, could be inventory obsolescence or product life cycle, right? The product life cycle, if the product is at the declining stage, okay, then you would not want to have high inventory level because you won't be able to sell those items in a quick manner. So in those cases, you would also want to have inventory levels very low. Okay, so once you classify your inventory items into A, B, or C, the next step would be to use that inventory classification to develop safety stock level. On Class A item, since the Class A are more critical for you than B and then C, you would want to keep your service level very high on Class A items so that you don't face any stock outs on Class A. Similarly, Class B, less important, so you'd want to maintain less customer service level, and C is the least customer service level, okay, because if you have any stock out, the effect will be not that high, okay, on your supply chain. Okay, so in my example, I'm going to present you how we do multi-criteria inventory classification and how we set the safety stock level on those items to optimize the total inventory cost. Okay, so in your screen, you are seeing some data, and this is an example of 47 items, and this data has been taken from Ramanathan 2006 paper, and you see the link in your screen. Okay, so the data contains average unit cost, annual dollar usage, and lead time for 47 items. Okay, so these are the three criteria we are using in multi-criteria example. Okay, so next step what I have done is I'm gonna unhide some table. So what I did, I converted each of these values on all of these three criteria into a scale of 0 to 1. So we call it normalization. Okay, that gives us easy comparison between different values. Okay, so I did for annual dollar usage, average unit cost, and lead time as well. Okay, so and the next step would be to set which criteria is more important or less important for you. So you would apply weight according to that. In this example, I have put lead time as a third most important criteria, so I just put 1 here. Average unit cost, I put 2. That tells me that average unit cost is 2 times more important than lead time. And I'm putting 3 for annual dollar usage, and that tells me that annual dollar usage is 3 times more important than lead time. Okay, so in order to come up with a total score on each item, what I'm going to do, I'm going to multiply the score of annual dollar usage with the weight of annual dollar usage. Then I'm going to add average unit cost times average unit cost weight plus lead time, then lead time weight. Okay, so you can see here G times K, H time L, I time M. Okay, that gives me a total score for each inventory item on these three criteria. Okay, selection of the criterias totally depends on your choice, your judgment, and your industry and your operations. For some people, lead time can be more important because they would want to keep inventory level low on those items that have a shorter lead time. So in that case, they would put lead time as a number 1 most important criteria, and they would rate inventory items according to that and would apply the weights. Similarly, some people can put annual dollar usage as more important criteria or the most important criteria if they want to make sure that they would keep inventory high on those items that has higher value based on historical data. But regardless, whichever you put a high or less important criteria, but the method is same. You apply weight on each criteria and then you multiply and individual score with that weight and you get a total score. Okay, and then what you do, you sort from largest to smallest to see which items have scored higher than other items. Okay, so in my case, so item 2 has the highest score, and then item 1, and then item 3, and item 4. Okay, and based on and then I also converted the total score into the scale of 0 to 1. In other words, I normalized the score, total score of each inventory item. The next step would be to classify those inventory item into A, B, or C. For that to happen, you have to decide what would be the transition point between A to B. In my case, I am putting 50% as a transition point between A to B, meaning that total score, if above 50% for any given inventory item, I'm gonna classify that inventory item as A. Any score that is between 50% and higher than 20%, I'm gonna classify as B, and less than 20% or equal to 20%, I'm gonna classify as C. Okay, so these are arbitrary levels. You can set those transition levels according to your understanding and the judgment. Okay, the idea behind is I want to keep A item less than B item than C item. Okay, because for me A item are more critical than B than C. Okay, so I want to maintain the high inventory level on A items. Okay, but I don't want to keep high inventory level on too many items, so otherwise my inventory cost would go too high. Okay, that's why I want to keep A item very small, and I would set a high customer service level on those items. So next step is calculate the safety stock levels on each inventory items. Okay, for that you need to know the safety stock formula. So safety stock formula selection is based on the variability in lead time, also based on the variability in demand. Okay, in my case, I'm assuming that I do not have any variability in the lead time for any given product, so I'm only considering the variability in demand. Okay, for that I'm showing in the screen 3 different formulas. You can use either one, and these 3 formulas can be used where demand is variable but lead time is not variable. Okay, most of the cases I use this formula. Okay, but there is no hard and fast rule. Okay, so but you have to be consistent. If you're picking one formula, use that formula for all the inventory items. Okay, okay, and then you set the customer service level on class A, class B, or class C. Since class A is more critical or most critical, so you don't want to face any stock out on those items. Okay, so you would want to keep very high service level on those items. How you can do that? You can use Z-score, okay, to relate with the customer service level. Okay, for example, class A item, if I want to keep 95% customer service level, okay, so meaning that 95% of the time I would want to make sure my inventory is available on class A item, so I would set 95% on class A, and I would go into normal table, Z table, and see what is the Z score against 95% value over there. Okay, and I would use Z score here and calculate the safety stock for all the inventory A inventory items. Similarly for class B, I have put here 90% for class B service level. So in the Z table or normal table, I will pick a Z value against 90% value there, and I'll put in this formula and calculate the safety stock for B items. Similarly, for C items, I have put 80% service level, and I will take Z value from normal table and then plug in here and calculate the safety stock for all C items. These service level totally depends on your supply chain or your judgment or your targets. These levels 95, 90 or 80% are just for example, just to show you how you can calculate the safety stock against different customer service level. Okay, so in this formula I have used 47 items, but in your world it could be 1,000 or more than 10,000. Most of the time I have more than 10,000 items. Okay, so in your industry, if the number of inventory items are too high, I'm not gonna worry too much about it. You can use the same method to classify those inventory items and then calculate the safety stock level. So the multi-criteria inventory classification would make sure your inventory level or total inventory cost and availability is optimized based on the criteria you are setting in your system. And any fluctuation on these three criteria would affect your safety stock level. Okay, so if lead time goes up or down for any given item, it would impact the classification for that item as well. But in the single criteria, since you are just using one criteria in that case, so your inventory level, you cannot control your inventory levels if the values on other criteria are changed. In other words, your inventory levels would not get optimized against other variables in the system. Let's put it this way. Okay, the more criteria you use, the more balancing act you are applying on the inventories for your system or for your industry. Okay, but whatever criteria you are using, it is very important for you to know what is more important and what is less important, and based on that you put the weight. Okay, so that's all about multi-criteria. Oh, one more thing. In this example, I have used 3, 2, and 1 as a weight. This is based on my judgment. Okay, there are other methods that can help you calculate the weights. One is analytic hierarchy process. Okay, and the other method that is being discussed in the literature is linear optimization techniques. So you can develop a linear optimization formula. Okay, and that would give you the total optimal score on each inventory item based on the importance level on each criteria that you have set in the constraint of that linear optimization model. Okay, the objective function would make sure the total score on each inventory item is optimized based on the importance level on each criteria. The formula would also give you the weights based on the importance level and the constraint you have set in the model. Okay, I have published some papers on this linear optimization technique, so if you guys have some time or interest, you can go ahead and take a look. You can see the link on your screen. Okay, thank you. Okay, so you just saw an example of multi-criteria inventory classification, and you also learned how we maintain and generate safety stock level using that classification. Now I think is the right time to start talking about dynamic inventory classification. Okay, in the previous example or in the single criteria, what you guys do, you input the values to the system. Okay, so you would be telling the system what are most important, less important criteria. Okay, and what are the transition point between A, B, and C, meaning that when your total score is below 50%, those inventory items would be classified as B, and if total score on the inventory items less than 20%, so those inventory items would be classified as C. Okay, But in the dynamic inventory classification, system is doing it for you. Okay, so once you develop an algorithm, in the future, system would be helping you to classify those inventory items, and you do not have to input any numbers or any of your formula in the system. Okay, for example, let's suppose your most important criteria is forecast accuracy. Okay, and you are linking your inventory classification and the safety stock levels with the forecast accuracy. So anytime the forecast accuracy in the system changes, it will trigger new inventory classification for those items. So here comes the predictive analytics. From predictive analytics, you know historically what was your forecast accuracy level on different inventory items. And predictive analytics would tell you what could be the forecast accuracy level for next quarter and the following quarter. Since predictive analytics basically talks about what might happen in the future based on the historical data you have. So predictive analysis would give you the numbers of forecast accuracy level for next and the following quarter. And then you can use that data to do the prescriptive analytics. Prescriptive analytics is basically using the predictive analytics outcome and results to help in the decision making, to help improve your operations, to help improve your customer service. This is what we are doing in dynamic ABC classification. So from predictive analytics, you have the data on the forecast accuracy. You feed into the system, okay, and your algorithm. So your algorithm would classify your thousand of inventory items based on forecast accuracy level changes. Okay, and in the same algorithm, you can put as a constraint what could be your total inventory cost. Okay, the set your level. So you can tell the system, you can adjust in your algorithm that your total inventory cost should not exceed X amount. Okay. So your inventory classification, your algorithm would be making sure your total inventory cost is not going beyond that level. Okay. At the same time, you are putting a customer service level on A, B, and C item in your algorithm. So the algorithm will also make sure your inventory levels, safety stock levels, are fulfilling customer service level that you have set in your system for A, B, and C. So this way, your total inventory cost would be minimized. At the same time, your on-time delivery or your customer service level would be improved. Okay. At the same time, those are conflicting objectives, but you're trying to make sure balancing those two out. Okay. And third thing, since you are doing those two and you're optimizing your inventory level at the same time improving your customer service, so your revenue for that quarter would also improve. Okay, how's that? So that's all about dynamic inventory classification. And what I do in my work, I also have set different transition point. Not that transition point that I was talking before, the transition point of forecast accuracy level. Meaning that if forecast accuracy level goes below 75%, okay, it should tell me how many of my inventory item would lose the previous classification. Okay, meaning that if my transition point on the forecast accuracy level I put 70%, meaning that above 70% I would make sure my inventory items would be classified as A. So if it goes below 75%, I would see how many of those items that had the forecast accuracy level less than 70% in the next quarter would lose the previous class A classification. So if I know that, I might change the customer service level in the system to make sure I'm reaching my inventory goal for the quarter. Okay, so I can do those adjustments. Okay, at the same time, by putting the right constraint in the model, and by putting the right relationship between the variable when I develop an algorithm. Okay. I hope you enjoyed this video, and okay, so before I close, in the multi-criteria inventory classification, if you want to know more about how we use linear optimization techniques on multi-criteria, do write to me. Put your comments in the comment section, and I will post a specific video on linear optimization techniques with respect to multi-criteria. Okay, so in this video I did not talk to you in much detail on that specific method, but if you guys are interested, I'm more than welcome to post a new video on that topic. Okay, so wait for my next video that will tell you a second example of predictive and prescriptive analytics in operational supply chain. Okay, and thanks for watching this video, and don't forget to subscribe my channel for new videos, because I will be posting new videos very quickly. Okay, that's my commitment to you guys. Thank you.